Hello dear students, this is your Jagan sir again and back to our YouTube channel Physics with Jagan sir, and we have successfully completed uniformly accelerated motion equations in the horizontal plane and in the vertical line yesterday, and today we are going to discuss relative motion in one dimension. Relative motion in one dimension. Now see relative motion in one dimension. Suppose, let us assume here an object is present, and suppose a car is present. In the car, a candidate is sitting, and here one more car is present. In this car also a candidate is sitting. Right? Now, with respect to origin, this point is at a distance of x a. This point is at a distance of x a. X a is the displacement of a r with respect to r. Means from origin is at a distance of x a. Similarly, x b is the location of b from the origin. Right? Now, can I say this is what is the distance between B and A? Right? This is what is the distance between B and A. And observe very carefully. Here, the point is the object, the person who is in the B, they has been observed by A. That is, can I say this summation is equal to distance or displacement of B with respect to A. Can I say displacement of B with respect to A? Yes, right. That means we can say displacement of B with respect to A is equal to here total distance xB minus xA. This is what is displacement of B with respect to A. Right? Now, similarly, let us assume a case. In this case, suppose they have velocities VA and VB. Now, velocity of B with respect to A. That means I am just differentiating xA, this formula. Let us differentiate equation number 1. By differentiating equation number 1, we will get VB minus VA. Right? That means velocity of B with respect to A. And you understand very carefully here. Here, this is velocity displacement of point B from the origin. This is displacement of point A from the origin. Similarly, these are also this velocity of B from the origin. Velocity of A from the origin. From the origin means from where original observer is present. Clear? Right. Now, again by differentiating equation 2, we will get acceleration of B with respect to A, acceleration of B minus acceleration of A plus A steady state. That is observer is at origin. A is the acceleration of B car with respect to the person who is at the origin, and A is the acceleration of car A for the observer who is from the origin. Now, A, that is the acceleration of B with respect to A is acceleration of B with respect to the observer who is inside B. So this is observation of acceleration of B with respect to the A car, but this is the acceleration of B with respect to the origin. This is acceleration of A with respect to the origin. Clear? I hope I am very clear so far. Right? Now, can we use this relative? That is, one is related to the other one. Can we use this relative representation in our uniformly accelerated motion equation? Yes, we can use this. Like we know formula V is equal to U plus A T. So velocity of velocity of VA, you can write like right? RA, whatever that might be. Here I am observing velocity of V with respect to A. You can also represent like velocity of A with respect to V, not at all a problem. That means like this A with respect to B, U, AB, A, AB, like this also you can write. That's not an issue. The observer is important, the object is important. Now let us assume for your clarity I will give you suppose. Let us assume this is the object. This is the observer. We name it as A, we name it as A. Right? And I told you formula. I told you as a formula as velocity of V with respect to A as velocity of V minus velocity of V. For your understanding, you can keep in your mind as velocity of object with respect to the observer is equal to velocity of object minus velocity of the observer. Velocity of the observer. Clear? This is the procedure you can keep in your mind if you want. Right. Now, uniformly accelerated equations we can represent like object with respect to observer V, and we can say this as u relative, that is velocity relative to one object with respect to the other observer, or the observer with respect to the object, like that is one is related to the other. Okay. Now you can write here V is equal to u plus AT as relative. You can write like this. That will be enough. You can consider from as A is with respect to B or B is with respect to say A. That's not an issue. Right? Similarly, we know S is equal to UT plus half AT square. So relative. You can also represent like this. Right? And next most important relation, B square minus U square is equal to 2A S relative. Like right. Now this is what the concept, and based on this concept, let us see some numericals, some basic and important numericals. Right. First one is a railroad flat car is traveling to the right at a speed of 15 meters per second. Now you can see this is a railroad car. It is moving in the forward direction with velocity of 15 meters per second. This is observing by a person who is on the ground. So velocity of car with respect to ground is equal to 15 meters per second, and we consider for our sake rightward direction as positive, leftward direction as negative, upward direction as positive, downward direction as negative. Right? Now velocity of car with respect to ground is 15 meters per second, and the second sentence in the question is someone is riding a scooter on a flat car. The velocity of the scooter with respect to the car is velocity of scooter with respect to car is equal to 10 meters per second. 10 meters per second. What is the velocity of the scooter related to the observer on the ground in case A and in case B? And case A says that the scooter is also moving in the same direction as the flat car. And here ultimately he is the observer. Got my point? Now, velocity of scooter with respect to car is equal to, as per our observation, in our concept, velocity of object with respect to the observer is equal to velocity of observer, object, velocity of object, velocity of the observer. Right? Now, here, whenever I am writing only one term here, this says that the observer is on the ground. That means here velocity of scooter with respect to ground. Here velocity of car with respect to ground. Okay? Right, they are asking us what is the velocity of scooter with respect to ground. This is what the question is. Yes, see what the velocity observer on the ground. Right, what is the velocity of the scooter related to the observer on the ground? That means velocity of scooter with respect to ground is equal to velocity of scooter with respect to car plus velocity of car with respect to ground. Clear? And this is the method of the first equation. Now come to the question A. Question A. Question A says scooter and car both are in the same direction. Both are in the same direction. So in question A, velocity of scooter with respect to ground is equal to velocity of scooter with respect to car. Velocity of scooter with respect to car given as 10. In the rightward direction, the scooter is moving, so 10. And velocity of car with respect to ground. Again, it is also moving in the forward direction, so we have fixed as 50. And ultimately, velocity of scooter with respect to ground is 25 meter per second. Got my point? 25 meter per second. Then the second point here, the second question in the second part of the question says, if the scooter is moving in the backward direction, what would be the velocity of scooter with respect to the observer again on the ground? That is, velocity of scooter with respect to ground here, and in the second case, velocity of the scooter is in the leftward direction with respect to the car, right? So we have to keep velocity of scooter with respect to car as minus 10 because it is moving in the leftward direction. In the second case, 10. Car, of course, it is moving. Car means railroad car. Of course, it is moving in the rightward direction only with a 15 meter per second. So I am keeping this as it is. Then the answer will be 5 meter per second. 5 meter per second. And here I am giving this question for your conceptual understanding. What is relative velocity first point? How we relate object and observer, and based on that concept, how can we approach numerics? This is what I am discussing right now. Clear? Then let us go with the second question. And second question says that two parallel train tracks run north and south. Suppose here, let us assume it represents north direction, and here one car is present, and it is moving towards the north, and here one more car is present, it is moving towards southward. Suppose let us assume it is southward direction, it is northward direction. Northward direction, right? Two parallel rail tracks run north-south. Train A moves north with a speed of 54 km per hour. 54 km per hour. And the train B moves south with a speed of 90 km per hour. 90 km per hour. B, right? Then a monkey running on the roof of the train A again is its motion. Suppose here a monkey is present, it is moving in the leftward direction. A monkey running on the roof of the train A again is motion with its velocity of 18 kilometers per hour. Right? 18 kilometers per hour with respect to the train A. So velocity of monkey with respect to train A is equal to 80 km per hour. 80 km per hour. Of course, it is in the leftward direction. Keep this point in your mind. Right? Then, what is the velocity of the monkey? First question, and ultimately we need to find what is the velocity of the monkey. And the first question is, as observed by the observer on the ground. Now, can I say velocity of monkey with respect to train A is equal to velocity of monkey minus velocity of train A. Right? Now, as I told you, if there is only one term, this is with respect to ground. With respect to ground, am I right? Then here velocity of monkey with respect to ground is equal to velocity of monkey with respect to A plus velocity of train A with respect to ground. Velocity of train A with respect to ground. Right? Now, what is the monkey? What is the velocity of monkey with respect to train A? Velocity of monkey with respect to train A is 80, but it is moving the leftward direction, so negative, negative. And velocity of train A with respect to ground, velocity of train A with respect to ground is 54 kilometers per hour. So 54 kilometers per hour. And of course, monkey is moving in the leftward direction and train is moving in the rightward direction. Train is moving in the northward direction. Monkey is moving in the southward direction. That's why here, and the answer will be 54, 80, 36 kilometers per hour. This is velocity of monkey with respect to ground. Velocity of monkey with respect to ground. For the observer on the ground. Right? For the observer on the ground. Velocity of monkey with respect to ground. Now, let us see the case B. Here what I am discussing is most conceptual and application oriented problems, so that you can be able to solve level of problems whatever at your examination standard. So, here an observer by an observer, as observed by an observer moving in the train B, moving in the train B. That means here you have to note one point. Now, observer is in B, that is velocity of monkey with respect to B. Velocity of monkey with respect to B. Right? As observed by an observer moving in the train, velocity of monkey with respect to the B. Now, velocity of monkey with respect to train B. Velocity of monkey minus velocity of train B. Can I write like this? Can I write like this? Right. And here, velocity of monkey with respect to ground, velocity of train B with respect to ground. As I told you, if it is represented with a single letter, you have to consider them with respect to the ground. Right. Now, here, velocity of monkey with respect to ground is 36, which we have already found in part A of the question. And velocity of train B with respect to ground, velocity of train B with respect to ground is B moves south with a speed of 90 km per hour. Right? So, here it is moving in the leftward direction, that is, it is also moving towards the south. So, this will be minus 90, and ultimately, which becomes 36 plus 90, which is equal to 126 km per hour. Right? So, these are the two basic questions. Let us see one more important question. It is one more important question. See, here a bird flies to and fro between two cars which move with the velocity v1 and v2. That means here a car is present. This car is, it is application oriented problem actually, not concept related. The concept we need to apply here. So it is application oriented and a critical problem. Previously, so many times they asked you the question. Previously they asked you this question in the examination. Right? Now, it is moving with the velocity v1. It is moving with the velocity v2. Right? And if the speed of the bird is v3, velocity of bird or speed of the bird. Speed of bird is equal to v3. And the initial distance of separation between them is d. The separation between these two is d. Right? Now, find the total distance covered by the bird till car speed. Now, can I use distance is equal to speed into time, because speed is equal to distance by time. So, distance is equal to speed into time. we know speed is equal to v3, and time value, the time is the time taken by two cars to reach each other, to meet each other. That will be defined by t is equal to separation between the cars, and velocity of, let us assume 1, and velocity of right, v relative, that is velocity of 1 with respect to 2, let us assume. Now that is t is equal to separation by velocity of 1 minus velocity of 2. But remember here very carefully, v2 is moving in the leftward direction, so we have to keep it is minus v2, right? Now time taken for the cars to meet each other is equal to d by v1 plus v2, d by v1 plus v2, right? Now distance is equal to v3, distance covered by bird is equal to v3 into time value is d by v1 plus v2. This is what is the total distance traveled by the bird before both the cars meet each other, right? Then next one is river man problem in context. It is one of the logical concept actually. See here, this concept says you have to relate two terms first of all, and I can try my AB best to make you be more comfortable in understanding this concept. First point is here, suppose it's a ground, on ground is moving, and here observer is present, right? And here the person is moving, let us assume velocity of man. He is moving with the velocity vm, that is velocity of man here. Now velocity of man with respect to observer is equal to velocity of man minus velocity of the observer, right? Now second concept here is, here observer is at rest position. So we can keep this velocity of man minus zero is equal to velocity of man. That is velocity of man with respect to observer who is on the ground. We can write velocity of man with respect to observer is original velocity of man. No, fine. Right. Now here Vm says that the capability of man, he can walk. Can I say like this? Vm is the capability of man can walk. This is what is capability. He can walk with a certain amount of velocity, right? Let us see the second case. Here the second case is little bit logical. Suppose here a swimming pool is present. Right? A swimming pool is present. In this swimming pool, suppose certain amount of water is existing. Right? And here a person is swimming in the water. Can I say now, he has walking with his capability, here this person has a special capability, a special speed with respect to water, he can swim. That is velocity of man with respect to water. Am I right? So he can able to move with that speed in water, as here the person is able to move in air on ground. This is what his capability. Similarly, here also this is what his capability, he can swim. Right? Now this is velocity of man with respect to water. Can I say velocity of man minus velocity of water? And again I am saying it, I am representing with a single letter here means that represents, that is with respect to ground. With respect to ground. So this is also with respect to ground, and this is also with respect to ground. Clear? Now, if of course we know that swimming pool will be at rest only. So velocity of swimming pool, the velocity of swimming pool will be, or water will be zero here. So can I say velocity of man with respect to ground is equal to zero. So velocity of man with respect to ground is equal to velocity of man with respect to water. That means if a person is standing here and observing, he is on the ground, and here with respect to him, his capital is velocity of man with respect to water. That means he is observing that he can able to move with this amount of speed. Clear? Now, next part is, let us go with an example for your class. And before that also I can give you an example here. Before we are going to solve the problem. Suppose here river is present. Instead of a swimming pool, if river is present. And river is flowing in the forward direction, that is velocity of water with respect to ground. Of course, river will move on the ground only. And if this river is moving with 5 meters per second. If the river is moving in the forward direction with 5 meters per second, and the person who is swimming, he has the capacity, velocity of man with respect to water is 10 meters per second. Let us assume it is not possible, still let us assume. Right? Now, what is his velocity if a person standing here and observing the situation? He says that velocity of man with respect to water is equal to velocity of man with respect to ground. That means from ground, here observer is present, he is observing. So velocity of man with respect to ground minus velocity of water with respect to ground. Right? Now, they are asking us what will be the man velocity with respect to observer. That means with respect to ground. This is what they are asking. That means if he is observed, how much would be the velocity? Clear? Now, velocity of man with respect to ground is equal to velocity of man with respect to water plus velocity of water with respect to ground. Clear? Now, velocity of man with respect to water is equal to, according to the question, 10 plus velocity of water with respect to ground is 5. Right? And both are moving in the rightward direction, that's why I consider both are positive. And ultimately, it gives us 50 meters per second. 50 meters per second. Clear? Then, based on this concept, let us go through a small problem. A swimmer capable of swimming in water B related to the water jumps to a flowing river. That is, velocity of man with respect to water is equal to even as B related to the water. Flowing water with the velocity, and water is flowing with the velocity of u. This is velocity of water with respect to ground. U value. So velocity of water with respect to ground, that river velocity is equal to u. U. Right? The man swims a distance d in downstream. That means he starts his journey at this point, and downstream means that means swimming in the direction of river, and upstream swimming opposite to river. Right? And here downstream is he is moving in the velocity of river, and he moved a distance t. He moved a distance t. Okay? In downstream and returns back to the original position. Again, he starts his journey from here and again comes to his original location. Again, he traveled d. But this is upstream because river is flowing in the rightward direction. And he is moving the leftward direction in second case. So this will be the upstream and this will be the downstream, right? Then back to the original to find out the time taken to complete motion. Now, time taken is equal to time taken for downstream plus time taken for upstream. Okay, time taken for downstream, time taken for upstream. Now, time taken for downstream is equal to P down is equal to distance traveled by velocity relative. Velocity relative. Here, velocity relative means distance by velocity of man with respect to observer. Suppose here the observer is present. Here is the observer. Right? Now, can I say this becomes d by velocity of man with respect to water. Velocity of man with respect to water is equal to velocity of man with respect to drop, velocity of water with respect to drop. So, velocity of man with respect to drop is equal to velocity of man with respect to water plus velocity of water with respect to drop. Right? Here we represent velocity of man with respect to drop. Clear? Right. Now, d by velocity of man with respect to water is given as in the question v. Right. Velocity v related to the water. So, velocity of man with respect to water is v, and velocity of water with respect to ground u. This is t1 value. And how we are taking this one is velocity of man with respect to water is equal to velocity of man with respect to ground minus velocity of water with respect to ground. So, velocity of man with respect to ground is equal to velocity of man with respect to water plus velocity of water with respect to ground. For your clarity, I am representing again how I am writing this one. From this, I am representing here for your clarity. Right? Next, T2 is equal to again distance by velocity of man with respect to ground, and it is in the upstream journey. That means we have to consider this as origin. From origin to leftward direction as positive, rightward direction as negative. Now, velocity of man with respect to ground, d by velocity of man with respect to water plus velocity of water with respect to ground, and we are considering down leftward direction as positive because he starts his journey from here and moving in the leftward direction. Now, d by velocity of man with respect to water is leftward I am considering as positive. That's why I am taking yes. And velocity of water with respect to ground, rightward direction. Here river is flowing in the rightward direction. So we are keeping it as u minus u. This is what is t. Therefore, total time taken is d by v plus u plus d by v minus u. And this gives us d of v minus u plus d of v plus u by v square minus u square. This is equal to dv minus du, dv plus du by v square minus u square. And ultimately, this becomes 2 dv by v square minus u square. This is total time taken. Right? I hope today we concluded with the relative velocity concept, and we have used as an application how the river boat or reverse river problems will be existing for one-dimensional relative motion concept. I hope you enjoyed the class, and if you have any queries, you can comment me in our YouTube channel, and you can follow for daily materials and weekend examinations our Telegram channel Physics with Jagan sir. Have a great day. Take care. Bye bye.